Hello guys, and welcome to your video lecture on the moon phases. Super excited to be teaching you all about what the phases of the moon are, and I hope that the next time you go outside and you can see the moon, you're able to identify exactly what phase it is in the sky and maybe wow the people that you're with, whether that be your friends or your family. So if you'll turn to your bell ringer section of your notebook, we are going to do some bell ringer questions. Remember, the purpose is to assess whether or not you understand the information or know it before we start, to see where your knowledge lies, and then we'll assess again at the end to see if you've learned what it is that we talked about today. So these are 4 true and false questions. You can write 1, 2, 3, and 4. Take your best guess, or if you know it, go ahead. Pause this, and then I'll go through the answers. So true or false, the moon radiates its own light. True or false? We know that this is false. True or false, a solar eclipse means that the moon comes between the earth and the sun. True or false? This is actually, hang on. This is true. The earth and the moon rotate at the same speed. True and false? This is false. The moon rotates and revolves at the same speed. And then true or false, the new moon means that the moon was born again. This is actually true. We get the word new moon from, I believe, Native American culture, who believed that each year or each month the moon was reborn into the sky. Okay, this is where we're going. These are our doodle notes today. Remember, doodle notes, I do expect you to use color. Starting here with the moon phases, and this is going to be new to you, so this isn't a memory check for you all. We haven't done our unit on the hydrosphere yet, but we will. I'd like to introduce you to the topic of tidal locking. So this is the idea that we always see the same side of the moon. This is because the moon revolves and rotates at the same speed, meaning that we will always see it we will always see the same side of the moon. Apologies. We call this tidal locking. Not exactly sure why we threw the tide in there, but I would like to remind you that the moon is responsible, or tell you for the first time, the moon is responsible for the tides on the earth. So the tides happen due to the gravitational pull of the moon on the earth. The moon does not have enough mass to pull the earth one way or another, but it does have the mass and the ability with gravity to pull on the earth's hydrosphere or water. Okay, that's what causes high tide and low tide. We have periods, the second triangle looking thing there, or rhombus. We have periods of extreme tides. This is because of a strong pull from both the sun and the moon. Happens during the new moon and the full moon. The tides are the most extreme. So if you are looking out into the sky here in Bladen County and you see a full moon, you can predict that at the ocean there, they are having extreme tides. So very, very low tides and very, very high tides. There's a big difference in range between the high and the low tide. This happens twice a month at the new and the full moon. And lastly, high tide is due to the gravitational force of the moon pulling on the Earth's water. I just talked about that. The moon doesn't have the capabilities to pull the entire Earth, but it does have the strength in its gravitational pull to pull the hydrosphere or the water towards itself. That's what causes high tide. Okay, here we are. We're going to pretend that this sunlight here is the sun, and this is the Earth and the moon as it travels along in its orbit around the sun, and the moon travels around in its orbit around the Earth. So remember, make sure you draw on this orbit right here. The moon revolves around the Earth at a counterclockwise angle. Same thing, the Earth is moving here at a counterclockwise angle from the sunlight. So Earth's path around the sun, let's label that ellipse right there. It takes the moon about 72 days to complete a revolution, right? Or the path of the moon around the Earth. I'm missing path there. What I want to bring your focus to first, please, because these are open circles for you, is the idea that only half of the moon is lit up from the sun. So only half, and that half is the side of the moon that's facing the sun. So at any given time, no matter how much of the moon that we see on Earth, how much is lit up to us, half of it is always lit up. So that's what this is showing you right here. So you see how only half of it is lit up? Doesn't matter, and it's always the side of the moon that is facing the sun, no matter where the moon is in proportion or in relative to the Earth. The half that it faces the sun is always lit up. So I want you to draw that in on your own diagram. So shade in half of it, leave the other half blank to signify that it is lit up. And then we're going to talk about that. So there was a pretty complex worksheet I've done with students before, but it's not going to be something that we're going to do. But I do want to talk to you about this idea that as the Earth, or as the moon rotates around the Earth, we are starting to see different parts of the moon lit up. So right here, right here and right here, because most of the sunlight lit up, or the sun facing moon side, is facing away from us, we're going to see just a tiny bit, or none at all, of the moon lit up. So this would be a new moon or a crescent moon. And then as we go towards in a little bit, maybe we see a little bit more of the moon here, because more of it could be visible to us. And here still a little bit more. And here a little bit more still. And here we see all of the moon, actually. We'll see the entire half that is lit up on a full moon. And then we see a little bit less, and a little bit less still, and a little bit less, until we get all the way back to the original position of the moon to the Earth. So if we want to look at that a little bit more in depth, here's what you would actually see. So this is what you would see. So though it doesn't show it just yet, I want you to think that these are the moon phases that are happening when they're in the positions that they are on the graph. So if you need to draw some lines, you can draw some lines to kind of match those up. So here's a new moon. Remember, a new moon signifies a new moon is going to be completely shaded. We won't see any of it. That means, because we're not seeing any of it, that means that the entire half that is facing the sun is facing away from us. So the moon is in between the Earth and the sun. And then as the month progresses, we see the moon start to grow a little bit into a waxing crescent phase. Crescent stands for this crescent shape you're seeing right here. Waxing, if you can, I'll move myself. Waxing is going to signify that it is getting brighter, or it's getting bigger, right? Because we can't actually see any of this. We only see this part of the sky. And then after the waxing crescent, it grows a little bit more until it finally reaches the first quarter phase. And then we're still getting brighter, so we're still waxing, but we call this shape right here with a little crescent that's not lit up, we call this a gibbous. So we're still getting brighter, so we call it a gibbous, or a waxing, and then the shape is a gibbous. And then eventually we have the full moon, where we're seeing the entire half of the moon that is lit up. We're seeing that because the Earth is now in between the sun and the moon. So we're seeing all of it. We're seeing the entire lit up side. And then as we begin to move around our orbit and the moon orbits around us, we start to see less of it. And when we see this phenomenon of it getting darker, we call it a waning moon. So we're waning because it's getting darker, and the shape here is the gibbous. So we put both together, we get waning gibbous. And then we're losing even more of our moon as we travel along in our orbit. We call this the last quarter. We lose a little bit more till all that we have is just a little sliver left. Remember, we call that sliver a crescent. And then, because it's getting darker, we're calling it waning until eventually we're back at that new moon again. Okay? And it takes about 28 days, 27 days for this full cycle to happen. It's something you can see in the night sky tonight if you start tracking it. You might not be able to identify whether it's waxing or waning until you see a couple of the moons in the sky, but you should be able to identify the shape at least if you can see the moon. Remember, it takes about 29.5 days to complete the cycle of phases. So about the same as it takes to complete one revolution around the Earth. So remember I told you your rotation and your revolution of the moon are the same. That is why we only see the same side of the moon at all times, and then we call that tidal locking. That's our phenomenon. So go ahead and review these. We're going to do a lab on this if you are here in class with me. If you're here at home, this is also going to be an opportunity for you to do the lab as well. There will be a separate video for that. So enjoy. I hope this helped you understand a little bit more about the moon phases, and we will touch base later with our lab. Have a great day.